Hello and welcome in the topic of design of IC engine components. So today we will discuss about the how to design the piston, which is the important part of the IC engine. So piston, you can observe the diagrammatic representation of the piston. So it is the reciprocating part of the IC engine. It transmit gas pressure force to counter shaft through connecting rod. So the function of the piston is nothing but it is a transmission of the gas pressure or force uh, to the crankshaft through connecting rod. Then it compresses the gas in compression stroke. Then it seals inside portion of the cylinder from crankcase, that is the piston rings. Then takes side thrust resulting from the obliquely of the connecting rod, then it dissipates the heat from the combustion chamber to the cylinder wall. You can observe here this topmost component is called as a piston. This is a piston head, then piston rings, then gudgeon pin. So by using gudgeon pin, we can connect the piston block to the connecting rod. Then this is a connecting rod, small end, and this is a big end or bearing end. So this will be connected to the crankshaft. Again, this is a second diagram which represent the piston. So this is a piston skirt. Then rings or grooves to fit the piston rings. So this is a diagrammatic representation of the piston block. So here you can observe the piston block. So this portion is called as the piston head. Then this is a skirt of the piston. Then this is a slot for gudgeon pin. This is the slot for piston rings. So here you can observe the piston head or crown. Then groove for compression ring. So these are the groove for uh, compression ring. This is called as a piston barrel. Then this is a piston pin included inserted into the this slot. Then this is a skirt of the piston. Then this is a ring section. Then this is called as the top land and this is called as the bottom land. So this is the diagrammatic representation of the piston block. Next is the piston rings. So the function of the piston rings is to absorb the fluctuation in side thrust. Then it is avoid the leakage or it is a leak proof, and it transfer the heat from piston head to the cylinder wall. So there are two types of piston rings are used. One is a compression ring and second is the oil scraper ring. Then the material used for piston rings are grey cast iron as well as alloy cast iron can be used. The number of piston rings, the compression rings are for aircraft and automobile engine, it will be equal to 3 to 4. And for stationary engine, it will be between the 5 to 7. So the number of piston rings, that is the compression rings are maybe 3 or 4. And for stationary engine, the piston compression rings are 5 or 6 or 7. Then one oil scrubber ring is preferred for the aircraft and automobile engine, but the number of oil scraper rings are used between 1 to 3 number, or 1 to 3. Therefore, this is the diagrammatic representation of the piston ring. So this is a top compression ring. Then this is second compression ring. These are the two oil rings. Then expander spacer is also there. So these are the number of rings that can be inserted into the this groove, so that there will be the uh, avoid the leakage of the fluid and proper working of the piston block and piston into the cylinder. So to avoid the vibration and also transfer the heat from the piston head to the cylinder wall through the compression rings or piston rings. Next, the width of the top land and ring land are calculated by using the formula H1 and H2. So H1 is equal to the thickness of the head to 1.22 times the thickness of the head, and H2 is equal to 0.75 H to TH to 1 times TH. That is the thickness of the head. In piston barrel, the thickness of the piston barrel at the top end in mm is calculated by using the formula 0.03 capital D plus B plus 4.9 number. So capital D is the bore diameter of the cylinder, then small b is the radial width of the ring in mm. Therefore, next will be thickness of piston barrel at open end. So that will be calculated by the formula T4 is equal to 0.25 T3 to 0.35 T3. So it will be lies between 0.25 times T3 to 0.35 times T3. Next is the piston pin, or it is also called as the gudgeon pin. So the function of the piston pin is to connect the piston block to the connecting rod. So it connects the piston and connecting rod. Then end movement is restricted by circles. Two criteria, bearings and bendings, are considered in case of the gudgeon pin. So there will be two types of functions can be considered. So the piston pin or gudgeon pin acts as a bearing, as well as it will avoid the bending of the bending moment, or it avoid the bending failure of the components. So the piston pin is the connecting part for the connecting rod and piston head. So here you can observe that the piston pin is inserted between the eye of the small eye of the connecting rod and piston block slot. Then next one is the bearing consideration. L1 is equal to 0.35 times bore diameter. So these are the standard dimensions for the piston pin. Then force on the piston is calculated by using the formula pi by 4 d square into P max. Then the resisting force is calculated by using the formula PB1 into D0 into L1. So PB1 is nothing but bearing pressure at a bushing of small end is equal to 25 megapascal. So the bearing pressure at a bushing of small end is equal to 25 megapascal, and DI is equal to 0.6 times DO. The mean diameter of the piston bushes are 1.4 times DO, or that will be equal to 1.5 times D. 0 for aluminum alloy material, and for grey cast iron material it will be 1.4 D0. Then next one is the bending moment considered on the piston pins are the sigma b is equal to mb by z, and z is calculated by I upon y. Therefore, mb is equal to pd upon 8, and I is calculated by pi into d cos raised to 4 minus di raised to 4 by 64, where do is the outer diameter of the cylinder and di is the inner diameter of the cylinder. So in this, for case hardened steel, the bending stress, so that is the sigma b is 84 Newton per mm square is considered, and for heat treated alloy steel, the bending stress will be equal to 140 Newton per mm square. Therefore, the piston clearance is 0.0375 to 0.1875 mm is considered. Next, piston ribs are there. The design of piston ribs, as a thickness of the head is greater than 6 mm, so ribs are required. Therefore, the piston ribs rib thickness is equal to always thickness of the head divided by 3 to the thickness of the head divided by 2. So it will be either 14 to 21. Therefore, we have selected the rib thickness equal to 18 mm. Then requirement of cup. So the L by D ratio is 1.2 here we calculated, but L by D ratio here comes as less than 1.5. So cup is required. So the radius of cup is always equal to 0.7 D. Therefore, the 175 mm radius cup is used while designing the piston rig or cup for the piston. Thank you for watching.